Today we're going to study Boyles Law in addition to Gay-Lussac's Law. And we're going to start with Boyles Law, which states a relationship between pressure and volume. When you decrease the volume of a container, so imagine a container that can change its volume. So if you could squeeze a container and make its volume change, and if you could decrease the volume of the container, you would make the particles get closer together, and if the particles were closer together, the collisions would increase, and that would make the particles hit the walls of the container more frequently, and that would make more pressure. So as the volume, as I said, would decrease, the pressure would increase. And as what happens to one of your variables, volume is a variable, as the opposite happens to the other one, we call that an inverse relationship. So we say that they are inversely proportional to each other. When one goes up and the other goes down, we say they're inversely proportional. So the equation we say is that PV equals K. So if we were to take pressure times volume, you would get a constant, but we typically use it in the form of P1 times V1 equals P2 times V2. This is the form of the equation that we're going to use right here. Meaning if we have one set of conditions, that's what the little subscript 1's mean, P1 times V1, the product of our first set of conditions, equals the product of our second set of conditions. Alright, so we're going to do a couple sample problems. What we want to make sure that you do is that you set up the equation correctly. And so what you want to do is write a table. So you're going to make P1, V1, P2, V2. As we learn more gas laws, you're going to want to check to make sure which gas law you're using. And usually you can do that by looking at all the numbers given in your questions. So I have liters, so I know that that's a V. I have KPA, as we learned in our prior lesson, that's a unit for pressure, and I have another KPA. So I have two pressures. When you have two pressures, you know one is going to be P1 and the other one would then be P2. And since I can read, I know that it says the volume, if the volume of the lungs is 2.38 liters during exhalation, and the pressure is 101.72 kPa, I know that this and this value go together. Because they go together, if I put the 2.38 liters as V1, then I know the 101.72 kPa is going to go as P1. And then that means that my 100.01 kPa is going to be my P2, which means when they ask for what is the volume, that's going to be my V2. So I write my equation, P1 V1 equals P2 V2. And I plug in my numbers. P1 is 101.72 kPa. V1 is 2.38 liters equals P2 is 100.01 kPa, and V2 is my question mark. Now solving for this, I would take my 100.72 kPa times 2.38 2.38 liters, and then I would divide by the 100.01 kPa, and that way I would isolate my V2. I would end up with my answer, which is, I'm going to keep about 3 numbers, and that would be about 2.42. My units, my kPa would cancel, and I would end up with 2.38 liters. Now, if you like to go ahead and show the work, that would be 101.72 kPa, algebraically, times 2.38 liters, divided by 100.01 kPa, so that your kPa would cancel, and that would be 2.42 liters. Alright, my next sample problem. If a scuba tank that has a capacity of 1.00 liters is filled with air at 500 kPa, so I have a V and a P, so those are my V1 and my P1. What will the volume, so there's my V2, and here's my P2. So I'm going to set up my P1, V1, P2, V2. I have 500.0 kPa. My V1 is 1.00 liters. My P2 is 702.6 kPa. And my V2 is my question mark. So I set up my equation, P1 V1 equals P2 V2. P1 is 500.0 kPa. V1 is 1.00 liters. P2 is 702.6 kPa. And my V2 is my question mark. Again, that's 500.0 kPa times 1.00 liters. I'm going to divide by that 702.6 kPa to get it on this side. That means they're going to cancel out, and that will isolate my V2. Plug that into my calculator, and I get 0.71 liters equals my V2. Now remember, if these are both inversely proportional, we can double check our answers. So let's go ahead and take the time to do that. I'll click on yellow to do that. How are we going to do that? Well, if pressure went down in the first problem, example 1, then my V should go up if they're inversely related. Did my V go up? Well, it went to 2.42 in my example number 1. So it went up, so that means I probably did it correctly. In example number 2, pressure went up. So if pressure went up, if they're inversely related, then V should go down. Did it go down? Yes. So that means I probably did it correctly. So there's Boyles Law. Come back and we will do Gay-Lussac's Law.